Hey students, today we are going to discuss why amplifier should have higher input impedance and lower output impedance for linear amplification. So first we will put the analogy of the amplifier circuit. So here you will be having the transistor, right? And here this part you will be having the input impedance, and here you will be having the output impedance. Okay, so this is a common port. Then here you will be having source resistance, so that for every source you will be having some negligible resistance that cannot be changed, right? Similarly, here you have a load impedance, that is RL. For every load you will be having some resistance. Okay, so here you need to know your output impedance should be very less. Okay, why? Okay, you want to know the reason, right? See, here you are giving some input signal, right? Here you are giving some input signal. Here this resistance cannot be modified. This is a source resistance. So we want our input signal which is enter into the transistor, that is amplifier circuit, it should be maximum. It should be maximum. That can be obtained only when you have a higher input impedance. You want high input impedance, right? So you can't reduce this RS, but you can reduce this value. You know this is value will be very less, and you can increase the value of RI, so that I can get this concept, that is a maximum signal to be reached in the input port of your amplifier circuit. Okay, with the voltage divider rule, I can write like a, so this I can write like a V in. So a source voltage, that is Vs into corresponding resistance divided by sum of your source resistance and the input impedance. You want to know this will be large, like a 10,000 if you take, this will be like a something like a 10 R. So this value will be very large. So it will be dominant. So here you will be achieve a condition, that is the large, that is a maximum amount will be reaching in your input of the circuit. Okay, with comparing your input signal. Okay, so that is a concept we want to know. Okay, similarly when you go for output section, that should not undergo any voltage drop, that is and the output impedance. That means I should have the low output impedance. Generally it's based on the application. See, there is a two type of amplifier we will use to study generally. One is a voltage amplifier, another is a power amplifier. In the both the case, your input impedance should be high and the output impedance should be less. If you want to say precisely, in the power amplifier, input impedance will be larger than your output impedance compared to, I am comparing with your voltage amplifier. Okay, so when you go for here, like we should not undergo any voltage drop in the output impedance, so it should be low as possible. So for specific application it will be differ. For antenna, if you take an antenna, it will be impedance will be in the range of 300 ohms, and if you take a loudspeaker, it will be have like a 8 ohms. It differ based on the application. Okay, final inference what you want to understand here is your output impedance should be low. Reason is it should not undergo any voltage drop in the output section. That is output impedance point. So whatever signal which you are amplified, it should be received in the output section without undergoing any drop. That is a very important point I want to insist here. Okay, but in the input section, we want to get our input signal maximum to the input port of your amplifier from the source signal. Okay, so this condition to be maintained when you are designing your linear amplifier circuit. I hope you understood. Thank you.